Welcome to lesson 6.2. Today we are going to go a little bit further. Yesterday you did the exponential functions with an a value so that there was a stretch or a shrink. Today we're going to add the h and the k. If you remember from previous functions, the h does a horizontal shift, the k does a vertical shift. And so they're just wanting you to look at that. Again, I remind you, as I said yesterday, I always use this x equals 0, y equals 1 as my vertex in these functions. That just helps to keep an eye on that. I also make note that my k-shift shows up like it did in the rational functions. My k-shift shows up best in this asymptote right here. Okay, so let's get going on this. It says use your graphing calculator to help you with this activity. So it's 2 to the x, 2 to the x minus 4, 2 to the x plus 6. So I'm just going to do that on the calculator right here so that you can benefit from it. If you have a calculator at home, then feel free to do it there. And if you've never used one, you might watch how I'm using the functions just to help you. First thing we do is we turn it on. Now we go to the window and we go 2 to the x. So we would go 2 raised to the alpha x. Now if you're looking at my screen, you could say, wait a minute, that was already in there. Yeah, I didn't have to replace it. I was just showing those who have not used the graphing calculator. 2 raised, use parentheses on this to make sure it all stays up there. Parenthesis alpha x minus 4, parentheses closed. And the next one, you can always hit clear on those so that they're not quite so confusing to put in. 2 raised to the parentheses alpha x minus, whoops, if you make a mistake, just go back with your cursor, plus 6, parenthesis closed. Okay, so the first equation that it's going to graph for us to see is the 2 to the x, then to the 2 to the x with the h shift being 4, 2 to the x with the h shift being a negative 6. Remember that it's a negative 6 because in our formula it's a minus h. So if it shows up as a plus h, then we know how it is. So this is how you should graph them. On here, they give you the 2 to the x, so you'll see it graph first. There it goes, just like how it is on here. Now here's the one that you need to add to that. This is the h shift of 4. And there, now you can see our window's a little bit off from here, so let's go back to the window and set it just like this graph. The x minimum is negative 8, so we always use this bottom key down here for negative 8. Our x maximum is positive 8. Our y minimum is negative 3. Our y maximum is about 9. That'll work. Okay, so this should give us a little bit better picture. There is the one that they have graphed for you, the parent function. Maybe you can see it a little bit better there. There is the h shift of positive 4 and the h shift of negative 6. So you can go ahead and graph those. It is just as you're probably thinking. Take that vertex, shift it 4 units this way and draw the graph, just like this one. Just copy paste it over 4 units, and then come back 6, put your vertex there, and copy paste it there. Compare the 3 graphs. How is the graph g of x related to f of x being the parent, g of x being the shift by 4. How is the graph of h of x related to f of x? So again, you're explaining the translations. Down on the next part, now they want to do a k-shift, which hopefully you can already have an idea how it's going to go. If you want to go ahead and graph it and then come back, that would be fine. We're going to plug in 3 raised to the x. That's what they've got in there. That's their f of x. Next one is 3 raised to the, and this time we need to delete the parenthesis because we want just an h shift, so it's plus 3, and then delete that parenthesis. Now we go down to the next one. It's 3 raised to the, whoops, delete that parenthesis, x, and then we have minus 5, minus 5, and then delete that parenthesis. Okay, now is our window about the same? No, it's not. So I would switch the window. I would switch it just like on your graph. It goes to about 6, 6, 6. So 6, 6, 6, and 6. This is always nice so that it just matches with what your paper has. Okay, so there's the one that they have graphed. And there is the shift going up 3. And here comes the shift going down 5. So again, I would move that vertex at the 1, or you may want to where it's an K-shift, it may be best to actually move your K-shift from the asymptote being at 0 up to being at 3, because it's really the asymptote that shifts to move the whole function. So it goes to 3, or move it down to 5. Now if you did it by way of the vertex, you would still be at the right location because the vertex goes up 3, that locates it at 4, or it goes down 5, that locates it at -4. But that might not help you to understand where the number 3 comes in if you're moving the vertex. Okay, go ahead and answer those questions regarding the translation. And now that brings us over this side. How do you think the value of h affects a function? I hope that you're seeing that it's another horizontal shift, all h values. In HK format, always do horizontal shifts, clear through all of your functions. How do you think the value of k affects? And again, I hope you're thinking the vertical shift up, down. Put it in your own words there. Okay, now it says use your graphing calculator to help you with this activity. What they want to do here is they want to show the difference in the a values being no a value, being a value of 3 and an a value of 1/2. I hope that you remember from the last lesson what this does, but in case you miss that, or in case you haven't really understood it yet, we'll put the 4 raised to the x there. Here we want to do, clear that, 3 parentheses 4 raised to the x. And on this one, clear that one, and we want to do 1/2. Now I could use parentheses and put 1/2 there, or else I could also do 0.5, and I'm just going to choose 0.5 parentheses 4 raised to the x. Oops. Not s, x. Okay. We'll get the same window as our graph here has. And our graph here has x going out to 6, so let's go to the window. 6 and 6, that's good. Y goes up to 9 on this one and goes down to about 3. So there we go. Now let's go to the graph feature. That is the first graph that they already have graphed there. That's with no stretch or shrink. There is the stretch of 3, and there is the shrink of 1/2. So literally what's happening when you put the half in front, you're taking this value of 1 and multiplying it by a half, or taking half of it, and that's why it crosses here. You're taking the value of 1 on the other function and you're multiplying it by 3. Well, 1 times 3 is 3, so that's why it crosses up here. This is why the 3 is referred to as a stretch, because it's stretched away from the x-axis, and the 1/2 is referred to as a shrink because it shrinks the distance to the x-axis. Okay? And then they have some reflect questions asking you to compare the 3 graphs, how the a values affect, and then it asks you, without graphing, explain how this graph compares to this graph. I would expect you to explain the transformation caused by this 4 as the a value. You would also need to explain your translations. Now remember, translations is the word within transformations that means to slide. I always think of the SL in there, meaning slide. So explain how it slid to the right or the left, and how it slid up or down in your own words. Now feel free to pause the video while you're writing all that stuff. The next thing that we're going to do is we're going to acquire an equation from the graph. One more thing, when you stop on these calculators, please make sure to hit second and the on button. That'll turn it off. Save us some batteries. Write an equation of the exponential growth function whose graph is shown. A, b to the x plus k. So there's no h shift, no side to side shift. First we find the value of k. Again, the k is from the horizontal asymptote. And we can see that our horizontal asymptote moved up to +1. So we know that k is +1. Okay. The next thing is find the value of a. Well, normally if we take our parent function and we moved it up 1, normally it would pass right through the 1. But we can see here where it shifted, and it shifted from being at 1 to 2. So we know that we've taken what would normally be something to the 0th power, or b to the 0th power equals 1, and I know it's crossing at 3 here, but I'm just imagining if this thing was shifted back down to the 0, that it's 2 units from it. So we're saying that b to the 0th is 2 now. Well, that tells us that a has to equal 2. Okay, so if the graph g of x is translated so that x-axis is the asymptote, then the y-intercept of the graph would be at 2. The current y-intercept is at 3. They're just having you shift it downward to meet your parent function. So the y-intercept of the parent exponential function is 2. This means that the graph parent function stretched vertically by a factor of 2. So a is 2. Okay, I'm watching for a student expert to be able to come in and explain that. So please think that through, how it shifts. I love it when you guys get down a way to explain it to others. Okay, so now find the value of b. The graph g of x passes through 1, 7. We should use that as our x and that as our y. If it passes through 1, 7, we can see that right here on our graph. And we can go to our y equals a b to the x plus k. Now we know our k is 1. We know that our a value is 2. We're searching for our b value. We have our x is to the 1st power, and our y equals 7. So now we just go up our PIMDAs to solve for this. So going up the PIMDAs, we'd subtract 1 from each side. We get 6 equals 2 times b to the 1st. Divide by 2. And we get 3 equals b to the 1st. Okay? So we know that our b value is now 3. If the graph is translated as as in part A, then it passes through oh boy, what they're doing is they're taking you down to here. If it's translated back down from here down to the 0, then it would be passing through 1, 6. Shrinking produces the graph of the parent function passing through 1, 3. In other words, they wanted you to shrink it back down, and then the graph of the parent function passes through 1, and the b value would be 3. I have a tendency to do it algebraically. You can totally shrink the graph down and move it down to see that. So we write the equation g of x is 2, 3 to the x plus 1. That's your total answer. That's the final answer. Make sure you always plug all your values back into the original equation. Okay, so now you can answer these reflection questions. How did you use the fact that g of x passes through 1, 7 to find a point through which the parent function passes? Again, you can go to the algebra like I did, or you can go back up to the graph and transform it back to the parent function visually and just see where your b value would be. How can you check that you wrote a correct equation? Well, we could certainly put it in the graphing calculator and graph it just to make sure that it matches perfectly, just like we have on these others. Okay, next page. On this page, they're wanting us to write an exponential growth function for a real-world problem. I like it when we model things. Please stop and read up above here. It says exponential growth occurs when a quantity increases by the same fixed percent over equal periods of time. You can model such growth using the following formula. They give you the formula, and then they explain what each thing in that formula means. You need to stop and highlight those. So now, Janelle invests $5,000 in an account that earns interest at a rate of 2% compounded annually. Write and graph a function that gives the balance in the account after t years. Then find the balance after 6 years. So the initial amount, A, is 5,000. The growth rate, switch 2% to 0.02. And the growth factor, remember it's 100% if it stays at the constant amount. But if it's an increase or an investment that is going up, then we add the 100 to the 2%, we would get 102% or 1.02 as a decimal. The balance A after t years is given by this formula. So we take 5,000, our initial amount, multiply it by our growth factor, and raise it to the years. Now they ask us to find the balance after t years. They also ask us to graph this. Well, we start initially at 0 years, we start at 5,000. So that would be 1.02 to the 0th power. Now I would plug in 10 and just plug it into a calculator and find the amount. So 5,000 times 1.02 raised to the 10th equals 6,094. So I would come up here, that's almost 7,000, over at 10, almost to 7,000. Then I would go 5,000 times 1.02 raised to the 20th. 7,429. 7,000, right about there. Now I'd go 30 years. 5,000 times 1.02 raised to the 30 equals about 9,000. 30 at about 9,000. And 40 years, 50 or 5,000 times 1.02 raised to the 40 equals 11,000. So you're seeing a very, very gradual increase. Okay, that's because the interest rate's fairly low. Now we need to show, find the balance in 6 years. We would go 5,000, 1.02 raised to the 6th. Do it on our calculator. 5,000, 1.02 raised to the 6th equals 5,630. Now you should 5,630, then it was 0.01. Now we should take this amount and make sure that it makes sense on our graph as well, just to kind of check it. 6 years up to about 5,000, almost 6,000. So that looks pretty close. Answer these reflect questions. Why is the y-intercept of the graph at 5,000? Think about that's 0 years of investments. That's what you start with. What does it represent? And then down here, answer this one. She decides to invest money into an account that earns interest at a rate of 4% compounded annually. How would the graph for the exponential growth function compare to the one that you graphed above? I want you to take an estimate of what it would look like, and then when you come into class, grab a calculator and change your rate to 1.04 and see how close you came on that graph. I think that you'll have a pretty good idea. In class, we'll be doing the practice problems together. Thank you so much for tuning in for Lesson 2.